So we're back with part 2. So what I want to do is now open the repository in my desktop client. Okay, so I have all the same functionality that I have through the command prompt, but this will actually do some other stuff for me. So if I want to open my existing local repository, I'll click the plus sign. I don't want to create a new repository. I already have created the repository with that git init command. If I click on add, I can browse into my whoops, I'm not in the right place, of course. So I'm going to browse to my node git demo. I'm going to choose that. So I'm opening an existing repository. I'm not creating a new one. I'm just browsing to the same folder that we've already been accessing through our command prompt or our terminal.
So we're just adding the thing that we just did?
We're just now going to look at it by using the desktop client rather than command prompt or terminal.
Oh.
So then I'll click Add Repository. What does this clone button do? I'm not going to click it right now, but what would that do?
Just makes a clone copy of the repository.
From where? You're right. Where does it find the repository if we click clone? Right. It basically lets us take a repository that's on GitHub and clone it or make a local copy of it. So let's say Matt and I are working together. Matt starts on the project, and then I need to get a copy of Matt's code. If Matt has pushed it to GitHub and gives me the URL of that repo, I can clone it and it'll just sync and download a copy through the client. But I'm just going to click on Add. So we can see the commit we made through the command prompt here, right? I can see my change. So what we're going to do now, we're going to make another change. We're going to make a new file. And then this time, rather than pushing it to the cloud through the terminal, we'll just do it through here. Okay, so I've got my repository open. It shows me my first commit. So I'm going to go back to Windows, to my directory, and I'm going to make a new text file. I'll call it text file 2. And I'll just put in some text. This is the second text file in our repo. Again, the text is not important. In fact, I think the other thing I'll do, so I've created a new file. I'm also just going to find an images in my pictures folder, and I'm going to copy that in here as well. So our repo will now have 2 text files and an image. Right? These don't have to be text files. It can be anything. So also in Windows, I'll just go back to my pictures, go to sample pictures, and we'll grab the penguins.
Do we need to have penguins?
You don't have to do this, but I'm going to put it in here as well. So my first commit only contains that first text file, right? We've added 2 new files to our repository, so now we want to make a new commit that includes the new work that we've added. Presumably these are files we've been working on and creating. Okay, so I've got 3 full files here in Windows. And now when I go back to my GitHub client, notice changes, there's a little circle here, and it says there's 2 uncommitted changes. If I click changes, it shows me what got changed, right? I've got 2 new files here. So if I want to make a commit here where it says summary, this is where I put in my commit message, where at the terminal we typed -m and we typed initial commit. So now I can say, adding penguins and text file 2. So that's a description of what we've done in this commit. And we could add a more detailed description if we wanted to, right? Because maybe we're changing existing files and we want the other people we're working with to know what we've changed. We could use the description. So if I click commit to master, this makes a second local commit. It's not going to GitHub yet, but now I'll have 2 versions locally. So I'll click commit to the master branch. It says my commit was created, and notice my changes, it now says there's no uncommitted changes. So I've snapshotted all my changes. So now look what this tells me here. This is kind of useful. This shows me, there's my first commit. There's the second commit I just made. This blue one is indicating, hey, you've got a commit here that you have not yet synced to GitHub. So you've made a local snapshot, but this code is not on GitHub yet. If I go back and refresh my repo, we're still only going to see that initial commit, right? We don't see those two files because we haven't pushed it yet. So to push, all I do is click sync. And we'll talk about why it says sync and not pull in a minute. So when I click sync, you can see it's uploading. Sorry, that's for an update. So it's syncing to the GitHub site now. So now notice before that circle was a big round circle, that indicates it was a commit that hadn't also been synced. Once that's done, this becomes a little circle. And now if I go back to GitHub, now I've got two commits. So GitHub shows me the latest commit, but if I want to go back and see the earlier commit, here we go. So now I can see all of them. And if I want to browse my earlier version, I just click on this version. So here's the first version that doesn't have text file 2 or penguins. That's my first version of my application. And if I want, so I can go back, I can open up the code, or so I can browse it this way. So now I'm using this as an archive, right? Every commit I make and push gets stored. So now I've got all the versions of my code. So if I break something, I can go back and pull out the earlier version where I know it was working. Let's do one other thing. I'm going to go back to text file 1. Let's change it. Now, adding a new line to text file 1. So we're going to save that change. So we haven't added a new file. We've just modified an existing file. So let's look. Now we can still just do a new commit in the command prompt and push again. But I'll show you why using the desktop client for many people is friendlier. Okay, so I've saved my change. If we go to the command prompt doesn't tell us that anything got modified, right? I've changed something, but there's no indicator here. So not only does it tell me there's an uncommitted change in my client, but if I click on the file, it actually shows me visually what was modified. So if I'm working together with someone else, the GitHub, so if Scott adds some code or changes something in my file and my copy is different from the version online, the client actually shows you what was modified. In case maybe Scott took something out I had written that I think is important. I can see that. So it doesn't just show you, hey, the name of this file was changed. It actually shows you the details of those changes. So we'll change it here. So I'm going to make a new commit. So adding second line to text file 1. I'll commit this to the master branch and then I'll sync it again. So I'll make a new commit, and now again we have a new commit that is unsynced. We have a snapshot locally, we don't have it in the cloud yet. So I'm going to push my third commit to the cloud. If I go back to GitHub in a minute, we'll see that third commit. So no changes show here. And if I refresh, Now I've got 3. Here's my commit message. And also in the cloud, it shows me, so the red means this was the old version. The green is this is what got changed. So if we're working on an application on our own, this could be a typical workflow. Create the empty repository on GitHub, create a folder on your computer, and initialize a local GitHub repository. Now, we could also do that right through here. We can just create a repository locally if we want to. And then as we're working, we make new commits regularly to create a new archive, and then push to the cloud for backup.
But I guess the command was a little bit more simpler though. Like,
Up to you. It's totally personal preference. Some people, so Brandon said you like the command prompt, you're comfortable with it. Other people like this. I like that it provides the visual cues of the changes, but I'm actually more comfortable with the command prompt as well. So you can use either, whatever you like. Now, it gets slightly more complicated if we're working with someone else. Again, I'm going to go back to my example. I'm working with Matt, right? So Matt's got a version of the code, I've got a version of the code, and we're both working. So when I log into my machine in the morning, before I start working, what's the first thing I should do before I open my code editor and start changing things or adding files? Right, maybe Matt does his best work at 3 a.m. So Matt may have made changes and synced them to GitHub, where we're going to have an issue if I don't first get a copy of Matt's code and I better start making my own changes now, and then I push them, maybe we've changed the same file. And then we've got this conflict. So let's make a change online. We're simulating having our partner make a change and push it. And then we'll see what we need to do in order that we get that change before we start working. So let's actually go here. Maybe this is a good time for us to add a Readme file. So we'll go to my repository.
the wiki?
Let's create a new file. So we'll do this online.
Where'd you click? Wiki?
I didn't click anything yet. I'm just click the name of my repository. And there's a button here that says create a new file. So let's create a new file. We have to we'll call the file readme.md. We have to put in at least 1 character of text in order to be able to save the file. So this is our Git demo documentation. Can say whatever we want here, doesn't matter. Call it readme.md. If you give it a different name, it doesn't matter. I'm going to scroll down. We need to enter a commit message. So now we're entering our commit message to our 3rd different way. We did it through the command prompt. We did it through the client. And if we change our app, if we making changes online, again, we have to commit them. So adding readme. We don't want a new branch. We're going to commit it directly to our master. We're not worried about creating alternate branches. So I'll click commit new file. So now we have 4 commits, and our online version now has this new file, which our local version doesn't have. So again, we're simulating that this file was created by our partner and synced to our GitHub repo. So I'm going to close my client and then I'm going to reopen it. Okay, so let's say my partner put that file online at night. It's first thing in the morning. I'm going to start working on the application. So I open up my GitHub client. You don't have to close and reopen it. I'm just kind of simulating. We're in this workflow.
Pretend that you close all your applications.
I do pretend. We'll pretend. So the first thing I'm going to do when start working is I'm going to open up that repository. I don't need to add it again. I've already added it to the client, so now it will be in my list on the left and I can just click on it. Once you add that repository into the GitHub client, it'll be here every time. I don't have to go and add it every time I want to work on it.
Do you have to always create from the terminal, or can you create it from
You can create one from here. We'll do it in a minute. I'll show you how to do it. So if you don't want to use the terminal at all, you don't have to. Okay, so here's my COMP20. So it actually opens right back to whatever repository was open previously. So I don't even have to browse. So here's my version. I've got these files. So what I need to do before I start working, what should I do? In case my partner's been working and made a whole bunch of changes and pushed those online, I don't have those changes. How do I get those changes before I start working?
Is that blue dot? Oh.
Good guess. Nope. I want to, well, I can do a pull, or if I click sync, notice what it says. Pull changes from and push. So when you click sync, what this does is it actually does a pull first. It will download any changes from the GitHub site to your local repository, and then it will push after. So before I start working, I should click sync. So now you notice I've got, so now I get the Readme file. Okay, good. Here's the file, and if I go to my local file system, it's now downloaded it, right, at 922. It just copied that file down. So before I start working every day, the first thing I should do. Now, if this is my own project and no one else is working on it, I don't need to do a pull request because I have all the code. But if I'm working with somebody else, I better make sure the first thing I do is a pull request before I start working in the morning, right? In case someone else on the team has put up new code or made changes and pushed those to GitHub, if I start working, we may have a conflict. So it's key that you hit sync first.
Wait, you want to sync and do pull request?
No, sync does both.
Oh.
It pulls first, and then it pushes anything second.
Okay.
But so it's a good idea to do this before. Like I have nothing to push, so it just does a pull. Right? It won't push because I've made no changes. So it's a good idea to pull first thing when you start working, if you're working with someone else or a team of people. Okay. So I want to do two other quick things with this. One is to do exactly what Kaylee suggested. What happens if we're starting from scratch? Can we actually basically start here? Let's do it. So we'll do like a second demo, but we'll do it completely through here. Okay, so we're done with this little, we'll come back to this repo in a minute. We'll do one more thing with it after. So if I want to create a new repository, so I'm going to browse into my node folder. By default, it goes, they're created in your GitHub directory. So you could keep it here if you want. If this time I'm going to put it in my node. So I'm going to put it in my node folder again. And I've got to give it a name. So I'll call it Git Demo 2. So this will create a Git Demo 2 folder and automatically initialize Git. So instead of in the command prompt me browsing into the folder and typing Git in it, this is the GUI version of doing that. Okay, so if I click create, so by default it puts in these two the Git attributes and Git ignore, and if I go in, here's my folder. Right, so now we can go ahead and work. We can start building our pages, saving our files, and Git is tracking them. Then we can commit and push.
So I don't know if it's just specifically for the Mac client, but so when I started like connecting the first one we did, it put it in GitHub, and then for this it puts it in another.
It may be that just the path, so you may just have to change the path on the client.
You have to publish it. So it's just a local repository, and then you have to.
Well, it's still also here, right? I have a local Git Demo 2. Yes, you'd have to click publish in order to get it online. Because if I go to my GitHub account and browse my repositories, this is only local right now. This is not creating it online. This is only creating a local repo.
Should we push publish?
You could, yes. To get it online, that's what you would need to do. That would create an empty repository online. So if I click publish, Do I need a description? What I may have to do here, yeah, sorry. I think we have, before you can publish it, whoops, I didn't mean to close that. It's not that you need stuff in it. When I click publish, it didn't let me, so let me open it back up. Get to demo. If I click on settings and repository settings, under remote, this is where you need to create, you still need to create the remote version on GitHub and put in the URL to your remote repo here. I can't publish because it doesn't know where to publish to. I haven't specified. So I still will need to go back to GitHub, create a new repository called getDemo2. So I still need to create the blank repository on GitHub. So now I'll copy the URL, and in my remote settings I'm going to paste it. So this is what links my local repository to my online repository. Otherwise you can't push or publish because the GitHub client doesn't know where am I sending this code.
So every time we need to do a new repository.
Yeah, so if you're creating a new repository, not a new commit, but a new repository for a new project. So now I think I can probably commit and publish. Well, I can't because I haven't made any changes. I probably have to make a new, add a file or change something, make a commit, and then I can publish.
I click publish.
Sorry?
In the client for the reader and desktop, you can actually create a repository in there.
Okay, so you can create it in there as well. I'll try and click publish.
Just the plus.
Oh, through the plus. So right, so it did push, actually. It did push the two files that the client created. So if you're more comfortable using this and not using the command prompt or terminal at all, that's fine. You're going to become more comfortable with terminal because we're going to need it for running our Node apps anyway.
I don't know if this is just a Mac thing, but it doesn't create those two.
I think it creates them, but they're hidden on Mac, because notice it only has the extension. There's no file name. Mac won't show you those files.
So is that okay?
Yes, it's okay. The operating system considers these hidden files. It's like the htaccess file, right? When we created those in PHP. On Windows, you could see the .htaccess. On Mac, the file was there, but the operating system finder didn't show it to you. They're considered hidden.
There's a code you can use. You can type into your command line, and they'll show you
Right.
hidden file.
There's a way to enable it. Okay. So if you like using this, that's fine. I'm going to show you one other way you can interact with GitHub. Okay, so you've got the command prompt, you've got the client. I'm sort of sensing from faces people are generally following along and understand what we're doing. The last thing I'm going to show you is how you can interact with it if you've installed Visual Studio Code on your machine. Okay, so what I'm going to do is open up Visual Studio Code. And what I'll do, you'll notice there's a Git icon here. So if I click Open Folder and go to my node, I'll go into my Git Demo 2. Doesn't matter. Go into any folder, either of the ones we've done today, so long as we've initialized Git in that folder. Okay? So I'm going to select that folder. So here's how this might work. This might be your workflow, right? Let's say in here, I'm going to create a new file. I'll just put in a few basic HTML tags. So this is how we might use it in the context of actually building a web application. So just put in some standard HTML. So we'll say git from VS Code. So I'm just going to create an HTML page. And I'll save this one in here as index.html. Should have saved it that way first. I would have got all my code hinting. And notice now my color coding is working. Like now I get my Visual Studio Code hints and stuff once I gave it an HTML extension. So there's my file. So now, because Git is initialized in the folder, just like our desktop client, Visual Studio Code is monitoring uncommitted changes. So I've got one file that has yet to be committed, right? That's what the little 1 here is telling me. So if I click on this, click on Git, it actually lets me make a commit right from here. So I can put in, you know, initial commit. And then I think I want to click the plus sign. It says stage all. So it says this has been staged. And now, if I say commit, sorry, let me say commit staged. So I'll make my commit or commit all. And now if I click this, I can push or sync. So sync will first do a pull and then do a push immediately after. I don't need to pull anything. I'm just going to push. You can see it chugging along. So now I'm back, my Git is back at 0. And if I look at this repository on GitHub, that index.html file should now be in my online repository.
And sometimes it'll ask you for your information, authentication. I guess.
It may. So here's my second commit, and here's my index.html. So my file's online now. So in this case, and this is what Adam will do as well.
Is it authentication failed?
Authentication failed. I wonder under. No, under our settings. Okay. I've logged in here somehow, but I'm not sure how it knows where my login is. I think because I've saved my Git login with global in the command prompt, anything that uses Git can access that login. So some of you might like this workflow. Yeah, I'm going to use this as an editor. Now I don't even need a second application. Much like within Visual Studio, I can build my applications, and Git is integrated into my code editor. So if you use that editor from Adam, it has Git built in as well, and I think WebStorm does as well. So it's a good idea to kind of, what I would encourage you is to use all of the tools and then figure out which one you like the best, which works best for you. Okay, they all basically do the same thing.
So you'd be checking out all our work on our own GitHub, like we had in our GitHub
Yeah, so when you submit stuff to me, so you'll have to submit 2 labs today. Sorry, you'll have to submit them both tomorrow. Okay. So there's a GitHub Lab, which is basically just you doing on your own what we just did. I'm going to show it to you. I thought we'd see how our time goes. I'm not going to give class time to do it because it won't take long, and I would rather spend some time talking about JavaScript. Okay. I'll show you the lab in a minute. So yeah, when you're submitting code, all you have to do is create Git repository and submit the link to the repository on Blackboard. You don't have to upload your code to Blackboard. Just upload it to GitHub.
You already have all our GitHub links, I guess, also.
Well, I don't anymore because they're in the previous course and I don't have access to that course has been archived. So basically, you'll just need to submit a link to a particular repository.
Where, for your GitHub or?
Nope.
Oh, my.
Okay. So let me show you lab 1. Okay. I'll give you until tomorrow night. This won't take very long. It's just basically for you to once again do what we just did. Okay, so here's what I want you to do. You can kind of ignore this part because everyone has a GitHub account. So you'll create a repository called lab 1. Probably not a good idea to leave spaces in it. Wasn't very smart of me. Or call it COMP2106-lab 1. Okay, so you're gonna have to put a few things in your repository. The first file that should go in your repository is this text file. So put a copy of the lab document. So this is on Blackboard under assignments. Okay, so if you go into assignments, you can download a copy of the lab. So the first thing to do is create the local repository and initialize GitHub in that repository. And you can do it any way you like. You can do it through the command prompt or you can do it through the client. Okay. So you'll create a local repository and it'll have a copy of this document in there. Then I want you to make a commit and push, which will sync this. So the first commit will have just one text file, have this document in it. And that'll be your first commit. Then what I want you to do, so you'll commit and you'll make that repository. The second thing you're going to do is make a change somewhere. Make a local change, put in a new line of code or change something in here. Make a second commit saying, hey, I've made my first change to the lab instructions, and commit it again. So then I'll see your second commit with a description, made my first change. So you'll make that change locally and push it to your repository. So then you'll have 2 commits. Okay. Then what I want you to do, that change you'll make online. So you're going to change it online first, the way we created the Readme online. So then what you'll need to do is do a pull request to pull your online change down to your local machine. Then you're going to make one more local change and push it back. So all you need to do is submit a link to the repository, and I should see that when I click on your repository link, I should see 3 commits minimum. The first one will be the initial commit, where the document is unchanged. The second one is the version you've changed online and then pulled down to your machine, and the third one will be the change you've made locally and pushed back up. So there'll be 3 commits. And each time the text file just has to look a little bit different. You can just add a new line at the bottom of it is the easiest thing. Okay.
Also, like you go into click on the code, change the code that's in the file. Then
Yeah, just put a new line in. So here, adding a line online for your second commit, and your third commit, adding a new line locally. Okay. So you just have to do this by tomorrow night. Okay, and I'm recording this, so if you need to see the steps again, you can watch and kind of follow along. Okay? So all you need to submit on Blackboard is the link to your repo, and all I'm going to do to mark it is make sure I see 3 commits here, and I'm going to make sure the first commit shows me the raw file as I created it, the second commit has a new line you've added, and the third commit has one more line you've added. That's all you need to do. Okay? So you can use any method. You can use the command prompt, you can use the desktop client, you could do it through Visual Studio Code and their GitHub tool there. However you want to do it is fine. Okay. Does anybody have any questions about what to do?
Did you say there was 2 labs?
There is. So that will be lab 1, will be GitHub. Really, this shouldn't take longer than about 5 minutes. Okay. Lab 2 is going to be the JavaScript Lab. Okay. Any other questions about Lab 1?
Are you able to show us how to collaborate on GitHub?
Yes, but we'll maybe save that for another day. Okay. Because then we can get into branching and forking, and that's there. Actually, if you want to read about forking, if you just go to the help, there's a good example where they've given you a sample project. If you just go to the main GitHub page and click on fork and work together. So they've given you a sample repository here by a user called Octocat, called Spoon Knife. So you can go through this. This is how you can download a copy and create your own version of it. So I suggest this would be a good place to go through. And then you've also got this work together. So go through this first. Would be a good place to start. Okay. Any other questions about GitHub? If not, okay, I'm going to move on. So, one of the other reasons we're going to want to use GitHub is that's going to be our common way of deploying to the cloud. So I want to talk a bit about the cloud. We won't really get into it for a couple more weeks. In a nutshell, what's the difference? Like, what is cloud hosting? Why is it different, or how is it different from traditional hosting?
It's usually segregated into a bunch of different servers located in different locations, and it's scalable, so you can, if you need to get more bandwidth, you can set it that it automatically does it, so there's really no limit on it. Okay, so that's the one of the biggest benefit. It auto scales. On a traditional server, if your application needs more resources, you're only going to find out when it starts hitting bottlenecks and slowing down. Then you're going to have to pay more and maybe move to a new server, a higher powered server, get a dedicated server, etc. So cloud scales automatically, which is one of the big benefits. Anything else? Any other ways that it's different from traditional hosting, or any other benefits of using it? Well, let's look a bit more. Originally, basically, it was used for enterprise level. One of the reasons we need to know about it is cloud servers are pretty much the only ones that will run Node applications. You can't just call up, Joe Hosting Company and have them run a server that runs Node. They probably don't. Okay. So, has anybody used cloud hosting at all before? You've used it. Which provider did you use? You used Google. You used DigitalOcean? Okay, and what did you think of DigitalOcean?
I liked it.
I haven't used it. One of the things you guys actually get, if you sign up for a GitHub for Education, one of the things you get in there is a $100 credit for hosting at DigitalOcean. So they actually give you that as part of the GitHub student pack. They also give you a free domain name for 1 year. So you may as well take advantage of that as students. Okay. So the original main sort of inventor of this was Amazon, right? So a lot of large-scale enterprises are hosting. You've probably seen the acronym AWS, which stands for Amazon Web Services. So some of the other big players, DigitalOcean, Google, who else is in this space that you guys have accounts with?
Amazon,
Microsoft is one of the other big ones, right? And you guys, their cloud hosting platform is called Azure, which I sent out an email to you telling you how to sign up and get an Azure account. It comes with your DreamSpark subscription as a Georgian student, that you can use Azure for free while you're here. So basically, it's all about scale, as Vadim said. It allows us, the more users we have, basically, the more servers will run our application simultaneously. So we don't hit those bottlenecks. So we can maintain speed. The other way that economics comes into it is, the way cloud hosting works is we pay per use. So if you build an application in a traditional hosting environment, you're going to pay a monthly fee, regardless whether that site gets any traffic or whether it doesn't. Okay? And if suddenly you get so much traffic the server can't handle it, you're going to have to jump to a higher service plan. The way cloud hosting works is basically you're paying monthly or daily based on the amount you use. So to build a small site that's not heavily trafficked is going to be very inexpensive. And if that site usage ramps up, your costs will scale accordingly. Okay? So here would be a typical example. Imagine you were running You know, the Olympics are coming this summer in Brazil. Imagine you had to host the website for the Olympic Games. Think how many concurrent users that site might have. Right? How would you figure out what kind of server you would need? You don't. So the scalability means that if we get more users than we anticipate, we've got more servers simultaneously running our site. Okay? We also deal with this, spikes in demand. Right? So this is a big problem with traditional hosting. If we find a hosting package that will handle us at peak demand, let's say our client's going to pay $500 a month for that. Well, maybe their busy season is only 2 months of the year. If we get them a hosting package where they're paying $500 a month, they're going to pay that every month, even in the months where they don't need anywhere near that amount of resources. With cloud hosting, it's going to scale. So if their business cycle looks like this, they're only going to be paying those high costs in the periods when their site's busy. When they're slow, they're going to be paying less. So there's a huge financial advantage to this. Okay? When that spike ends, those resources, we can spin them down. Okay? So the cloud is used for all kinds of things. It's not simply hosting applications. We can host virtual machines. We can run other operating systems. We can run all kinds of networking. And also, obviously, one of the things probably we all use it for, in fact, we just did with GitHub, is cloud storage, right? It's a way of backing up our files that we've got remote access. You know, I had a student in class yesterday, an intro to web programming. During class, he tried installing a piece of software, and it accidentally wiped out, he said, 13,000 files on his computer. He was a little bit panicked. And I said to him, please tell me you have a cloud client installed on your machine. And he said, yes, I do. I can't remember what he had. I think he's got Google Drive. So any file he saves automatically syncs to Google's cloud, right? So he said, I'm actually downloading all my files back off the cloud that got wiped out by this software install. So you should never lose your files with cloud storage. It's all free, right? Yeah, we have limits, but you can just open a new account. If you're using Google Drive and you hit your storage limit, well, create a second Google account and use that for backing up. So it will do all of these things for us. They also tend to support, one of the other nice things about cloud environments, traditional hosting environments typically only host a few technologies. Many hosting companies, all they host is the LAMP stack, right? PHP, Apache, MySQL. We can't run anything else. Other hosts will also run Windows, so we can run ASP.NET and use an SQL Server database. But that's basically it. We can't run things like Node. We can't run things like Oracle. We can't run Linux or other kinds of things in a traditional hosting environment. In the cloud, we can run basically anything. When we log in later to Azure, you can see everything we can put up there. Okay. We can also configure things however we want. Okay. So we're basically build per minute, pretty much. So here are some of the things we can do. We get an online management portal. We can set up our own virtual machines, install our own operating systems. Cloud services allowed us to do all these kinds of things. Okay. So these are the type of applications that would come, for example, with Azure. So we want to run something like SAP. Anybody know what that is? Anybody heard of SAP? Yeah? What is it, Connor?
Like I just know it's for payroll, I think, because my mom works on it a lot. That's all I know.
There are two huge enterprise-level applications that are used basically. They're called CRM solutions, customer relationship management, largely used by human resources departments. There's two big players. SAP is one, PeopleSoft is the other. In fact, the college uses PeopleSoft. So if I want to log into the staff portal and see, for example, print my T4 slip or see my paycheck, that's all managed through PeopleSoft, which is another version of SAP. So we can run an application like that in the cloud. Azure would support those kinds of things. Okay. So we can run virtual machines. So let's say, for example, we want to do iOS development, but we don't have a Mac, right? Potentially, we could use a virtual machine running Mac OS to do Xcode for doing iOS development. Would be something we can do. So I'm not going to walk through this demo. So we'll get into also great for doing API development and hosting APIs, and we'll do this later. We can host mobile services as well. So pretty much any kind of app is going to run through here. So if we've got a mobile application, we want to serve it, we've got a relational database, obviously it'll support all kinds of databases. We can run SQL Server, we can run MySQL, we can run Oracle, we can run NoSQL databases, which is what we'll use in this class. We've got JSO, so we can run Mongo on Azure, which is great. We're going to want to do that later. So this is some of the things that we're going. I won't go into all of this. I think that's kind of enough. The rest of these slides are here in lesson 1 on Blackboard. Okay. One of the other things, as Vadim said, is the big cloud providers have servers all over the world. So again, we have users remotely. Rather than their internet requests having to travel, they can hit a more local server to them, which is going to increase speed. Increase speed and decrease bandwidth for them. Okay.
Also, DNS reverse doesn't really work on cloud servers.
Right. Okay. So we can get this free Azure. So we'll play around with it. We'll also play around with Heroku, which is another cloud hosting service where they give us access to 5 free sites, so long as they're non-commercial. So what you can't do is you can't put your own domain name on them. Like we have to run it as a subdomain, like mysite.herokuapp.com. It won't let you run it at adamrydell.com. If you do, they'll charge you, because then they know they're going to assume it's commercial. Okay, so we can play around with both. And in both cases, we can deploy straight from GitHub to the cloud, which is great. Push our repository to GitHub and let it run. So to show you what that'll look like, look something like this. If I log in. So I suggest, again, you don't need the account for today, but you will. So here are a few applications. So here is one I did from the fall. So if I click on my Heroku application and click on deploy, it's actually connected to this GitHub repository. So anytime I push changes, I've set it up to automatically redeploy. Now I can turn this off. I can disable this if I want to work for a while and not have my code automatically go live. But by default, this is on. So if I want to connect this to a different repo, I can click disconnect, and then I can reconnect, enter my GitHub credentials, or store them in here permanently, and then I can link to any repository. So no more FTP. All I have to do is make a new commit and push it to GitHub, and it can automatically be deployed. And I think somewhere in here I can even see the history. Yeah, if I go to the activity, it will show me here's all of the commits I've made to GitHub, and every time I've made a new commit, it deploys that new version to the cloud, so it's live online. So I don't need FTP. My source control and my hosting are all linked together. So being comfortable with GitHub is going to help us when we go here. This is what we will be doing. So for your assignments, we're going to want to deploy them online. This is how we'll need to do it. Okay, there's no FTP here at all.
So this is kind of like GitHub also.
Well, no, it's pulling from GitHub. So here was a sample I did for the assignment. And we can deploy from Dropbox. There's also Heroku has a command line. We can deploy straight from there if we want to, if we don't want to use it. So there's my repository. Okay, so this is what we will be doing and how you'll be posting your work in this class.
So we should download Heroku then now?
You don't need to download it, but you just sign up for a free account.
Okay. Is that how we're handing in our labs tonight?
Eventually, you can deploy either. I'll show you how to deploy here, and I'll show you how to deploy to Azure as well. And you can use either one. For the labs today, though, you don't need this. You just need the GitHub piece. Okay, but this is where we'll be going.
So this is you're showing us.
I'm showing you, yeah, what it will look like once we get set up with the cloud. And Azure will look pretty similar. We'll see that we can deploy from GitHub and see that deployment history. Okay. Any questions from anybody at this point? Okay, so you'll have some options, and I would encourage you to try them all. You can use Heroku for free, you can use Azure for free, and if you have the GitHub for Education, you've got that $100 credit, you can use DigitalOcean for free. So I suggest try them all and see whichever one you like. I don't care which service you use, or another one.
Are we supposed to use our school email for Heroku or just a person?
Heroku, it doesn't matter. You just create a free account and then you just connect it. It gives you 5 free applications. So if I create one more, it's not going to let me, but I can still create one more application because I've got 4. So that doesn't matter. Okay, why don't we take a break here? We'll come back at 10:05 and we'll kind of do a little bit of a JavaScript review, and then I'll give you your lab. So play around with JavaScript for an hour.